The purpose of this video is to explain something about Ohm's law. But first, I think we should start with a little bit of history. The Earth cooled. Dinosaurs roamed the Earth, but they were big and stupid.
Hey.
So we can skip a whole bunch of history. Eventually, in the late 1700s, when electricity was first being discovered, people knew that there was an electromotive force that tried to cause charges to move from one place to another. It caused like charges to repel each other and opposite charges to attract. Mr. Volta spent a fair amount of his time studying the properties of electricity and got a unit of measure, the volt, named after him as a result. Scientists also figured out that they could measure the rate at which charges pass a given fixed point. Mr. Ampere realized that these charges would flow down a copper wire in a manner much like water flows in a pipe. He devised a device for measuring the rate of flow, so his name got used as the unit of measure for the amount of flow of electrical current. The unit is the amp. People knew that much like pressure is needed to cause water to flow along a pipe, a voltage is needed to cause the electrical charges to flow along a wire. Folks referred to this effect as being a resistance. Now we come to the hero of our story, Mr. Ohm. After several false starts, he came up with a simple formula relating the resistance, the voltage, and the flow of current. If you divide the voltage by the resistance, you get the amount of current. People quickly realized that you could rearrange this so that if you knew any two of the three, you could compute the third one. Some friends of mine found it very helpful to have one of these, and a screwdriver, and also a cup of coffee. If you know the current and the resistance, but don't know the voltage, you just place your cup of coffee over the V on this. Voltage is the current times the resistance. If you know the voltage and the resistance, you place your coffee cup like this, and you can see that current is voltage divided by resistance. There is a point about electrical currents that seems to be obvious to some people, but less so to others. Imagine we have three wires that come together at some connection point, what some people might call a node. Some current flows this way. Another current flows this way. We know that no charges dribbled off and landed on the floor, so the sum of those two currents must have gone this way. If we take currents flowing towards the junction of the three wires as positive, and the current flowing away as being negative, then we can write a formal equation that looks like this. Finally, we have a rule about voltages. Imagine we hook up some parts with wires like this. We know that this jumper wire is 0.01 ohms end to end. I bought these resistors, which the manufacturer claims are 51 ohms, and for the purposes of discussion, we will believe them. To make the math easy, let's just assume that we force 1 amp of current to flow through this circuit. Using Ohm's law, we can work out the voltage that will be across each one of these three parts. We can add up the three voltages to get 102.01 volts, like this. From this, we can make two observations. The first is that nobody's going to notice if we just ignore the voltages dropped in the wiring. The second is a little less obvious, but if you notice the way I've been marking off with the red and black lines, you can see that 102.01 volts should really have been written as a negative voltage for the way I've been labeling my voltages. This is like if you go for a walk in your local park and you come back to the same place, you know you must have gone uphill the exact same amount that you went downhill. I have been doing electronics for quite a long time, and hardly a day goes by where I don't apply one of these things that I have shown in this video. The secret is that you often have to apply these ideas over and over and over and over again until you get the answer you need.